Hey students, up until now we have, I've been giving you the vector and you've given me things like the magnitude, you're able to give me the direction. Actually, this is the set of directions for finding that direction when given the vector, but we are going to work the other way around. What if you're given two parts of the vector, namely the magnitude and the angle? Can you revert back to component form? So you're kind of working backwards. Well, you can now because I've given you the formula here. So this is saying that the vector is equal to the magnitude times the cosine of theta for the horizontal component, and for the vertical component it is the magnitude times the sine of theta, which hopefully that makes sense to you because you're given, in other words, they're giving you the magnitude, which is the hypotenuse, and they're giving you an angle. So you should be able to find the two sides of this right triangle with that. So let's try it. Make sure you write this down and put these in your notes. And now let's try this. I want you to state the component. Do not approximate, use exact measures. And here's the problem. The magnitude is 4 and the angle direction is 30. So I'm going to go right back up here to this formula. So the vector is going to equal to the magnitude of 4 times the cosine of 30 for the horizontal component and 4 times the sine of 30 for the vertical component. Now we know the cosine of 30. The cosine of 30 is square root 3 over 2. So I'm going to take 4 times that, and the 4 and the 2 cross reduce, and I get 2 times the square root of 3. And so that is, of course, a horizontal component. The vertical component, the sine of 30 is 1/2. So I'm going to take 4 times 1/2, and 4/2 is 2. So this is it. Now notice that this has a square root. I didn't put that in my calculator. I know those trig functions, evaluating the trig functions without one, namely the unit circle. And when you're given something on the unit circle, I expect those answers to be exact. Exact means you don't approximate. If you get a decimal, that's an approximation. This is exact. Now I want to talk a little bit more about the directions that you're given because we're going to talk about bearings. There's this thing called azimuth. I don't know if it's azimuth, azimuth. I don't know. I know that it's, I think it's Arabic. And if you're given an angle in measurement only, it is assumed to be clockwise from due north. Now that is completely different than you've been doing because here's the deal. On the unit circle, we have used vectors and angles like this. You're going from quadrant 1, 2, 3, 4, and you're always going counterclockwise. But in these that we're going to be used, you're going to be going from the north. So if, well, let me just give you some examples in a moment. The U.S. Army calls these azimuths or azimuths, I'm not sure, but most people call them bearings. Pilot uses them. Anyway, you've heard the word bearings before. I stuttered, sorry. Okay, so notice I didn't say angle direction. Right here I'm saying a bearing of 50. So from due north, because compasses point north, right? 50 degrees is going to go clockwise 50 degrees. So it's going to look like this, and this would be their 50 degrees. So that's a bearing of 50. If it said a bearing of 150, well, so you're going to go 90, 100, 1, all the way to 150, you're going to be 30 degrees shy of that. And this is your 150 degrees bearing. Again, I went clockwise. Try to think about where the bearing of 300 would be. And think about that. I'm going to do it in just a second. Okay, hopefully you know you're 60 degrees shy of getting right back to north again. And there's your bearing. Now, of course, I'm approximating here, of 300 degrees. So I need you to write down these examples and these drawings, please. Okay, now if you are on a non-air transport like boats, things like that, they use their bearings like this. They'll say bearing north 20 degrees east. So read through these, and I'm going to draw those out for you, and I want you to draw them out as well. Okay, so the first one says north, so you look north. And then it says 20 degrees east. So in other words, it's saying you're 20 degrees east of that north. So of course, east is this way. So here is your angle. It's 20 degrees. 20 degrees east of north. Here, bearing south, so you think about, okay, I'm south, but it's going to veer 35 degrees east. So you go, oh, okay, so it's 35 degrees. And there is your vector. If it says, now this time you give a guess, and then I'll tell you what it is, bearing north 25 degrees west. Okay, hopefully you thought north, and then west of north would be this way, and that's 25 degrees. So there is that bearing. Okay, one more thing, and this is the physics bearings. Okay, on this one, this is how they talk in physics. And they will say, they'll give you angle and then the direction of the direction. I kind of prefer these. Okay, so it says traveling 25 degrees south of east. So if you're going 25 degrees south of east, this is east, right? And this is 25 degrees south of east. Okay, this one, moving, so you can tell it's physics problems, moving 30 degrees north of west. So think about it, if you're going north of west, here's west, north of west is right here, and that would be 30 degrees. And there's your angle, correct. All right, you try this one, rolling 35 degrees east of south. Okay, so hopefully you realize if it's east of south, it's got to go this way, and that's 35 degrees. There we go. All right, so when you're talking about angles for vectors, direction angles, in pre-calc, they're measured from the positive x-axis, which you already know. And yes, I will always make those distinctions for you. I will say the direction angle is, and you would go to what we traditionally use. If I say bearings, you go to the top. And you should, this number 2 and number 3, to me, you can't really mess those up. Or maybe you can. I don't watch me mess one up now, because I said that. Okay, so those are bearings, and we are going to be working on those in class. You're going to need these notes, and I will not have pity on those who don't have them. Yes, I will. No, I won't. We'll see. Take care.